everyone. Myself Maheshwar. So today I'm going to deal with the chapter that is Model 2 in fluid mechanics, that is dynamics of fluid flow. The dynamics of fluid flow is the study of the fluid in motion with the force causing the flow. So Euler's equation of motion. So consider a streamline in which flow is taking place in the delta direction as shown in the figure. Consider cylindrical element of a cross section A, that is delta A, and the length delta S. The force acting on the cylinder element are, that is pressure force, that is equal to P into delta A in the direction of the flow. Then pressure for that is P plus delta P delta S, that is P plus dou P upon dou S into delta S into delta A opposite to the direction of the flow, that is this direction. Then weight of the element, that is P rho into G into delta A into delta S. Let theta be the angle between the direction of the flow and the line of the action of the weight of the element. Resulting force on the fluid element is equal to the mass of the fluid into acceleration. Therefore, P into delta A minus P plus delta P into delta S, dou P upon dou S and delta S into delta A minus rho into G into delta A into delta S into cos theta. So minus dou P upon dou S into delta S into dA minus rho into G into delta A into delta S into cos theta is equal to rho into delta A into delta S into AS, where AS is equal to dV upon dt, where V is the function of speed and time. Therefore, dV upon dou A upon dou S into ds into delta t plus dou A upon dou t, that is equal to V into dou V upon dou S plus dou V upon dou t, d upon dou d upon dt is equal to ds into dt. Hence, if the flow is steady, dou V upon dou t is equal to 0. Therefore, AS is equal to V into dou A upon dou S. Substituting AS is equal to minus dou P upon dou S into ds into dA minus rho into G into dA into ds into cos theta, that is equal to rho into dA into ds into V into dou A upon dou S divided by rho into ds into dA. Thereby plus dou P upon rho into ds plus G into cos theta plus V into dou A upon dou S is equal to 0. Cos theta is equal to dou Z upon dou S. Therefore, 1 upon rho is equal to dou P upon dou S plus G into dou Z upon dou S plus V into dou V upon dou S is equal to 0. Therefore, dou P upon dou A rho plus G into dz plus V into dou V equal to 0. This is known as the Euler's equation of the motion. Therefore, integration dou P upon rho plus integration G into dz plus integration x into dou V equal to constant. Therefore, B into rho plus V square upon 2 plus Gz is equal to constant. That is therefore P upon rho into G plus V square upon 2G plus Z is equal to constant. This is the Bernoulli's equation. Therefore, P upon rho into G is equal to pressure head, V square upon 2 is equal to velocity head, and Z is equal to potential head or datum. So assumption that for the above equation, the relation is the fluid must be an ideal fluid. The fluid is steady. The flow is incompressible. The flow is irrotational. So these are the four conditions should be assumed while deriving that equation. So an example for this: water is flowing through a pipe of 5 centimeter in a day under pressure of 29.43 Newton per centimeter square and with the mean velocity of 2 meters per second. Find the total head or the total energy per unit weight of the weight at a cross section which is 5 meters above the datum line. So diameter is 5 centimeters, that is equal to 0.5 meters. Then rho is equal to P is equal to pressure 29.43 Newton per centimeter square, that is 29.43 into 10 raised to 4 Newton per meter square. V is equal to meters per second. And then Z is equal to 5 meters. We know the total head is equal to pressure head plus velocity head plus datum head. So pressure head is given by P divided by rho and Tg. plus velocity is equal to v square upon 2g and data is equal to z. So pressure is equal to 29.4 into 10 raised to 4, so 8000 into 9.81 v square is 2 square divided by 2 into 9.81 plus half 5, that is equal to 35.204 meters. The next problem, the water is flowing through a pipe having a diameter of 20 centimeters and 10 centimeters at the section 1 and 2 respectively. The rate of the flow through the pipe is 35 liters per second. The section 1 is 6 meter above the datum and section 2 is 4 meter above the data. If the pressure at a section 1 is 39.24 Newton per centimeter square, find the intensity of the pressure at section 2. So there are two sections at a section 1 and section 2. Okay, therefore d1 is equal to 20 into 10 raised to minus 2 meters. Q is equal to 35 into 10 raised to minus 3 cubic meters per second. Z1 is equal to 6 meters. P is equal to 39.24 into 10 raised to 4 Newton per square meters. Okay, then due is 10 into 10 raised to minus 2 meters. Z2 is equal to 4 meters. Then P2 is equal to how much? So applying the Bernoulli's equation, that is P1 upon rho into G plus V square upon 2G plus Z1 is equal to P2 upon rho into G plus V square upon 2G plus Z2. And we also know that Q is equal to A into V. Therefore, V1 is equal to 35 to 10 raised to minus 3 divided by 5 square by 4, that is pi into 0.2 is the square divided by 4, that is equal to 1.114 meters per second. And V2 is equal to 35 to 10 raised to minus 3 divided by pi into 0.1 divided by 4, that is 0.1 square divided by 4, that is 4.4456 meters per second. Therefore, P1 1 upon rho into G plus V1 square upon 2G plus Z1 is equal to P2 upon rho into G plus V2 square upon 2G plus Z2. So P1 is equal to 39.24 into 10 raised to 4 divided by 1000 into 9.8 plus V1 square 1.14114 that is square divided by 2 into 9.8 plus a 0.6 P2 divided P2 is equal to 1000 into 9.81 plus 4.446 the whole square divided by 2 into 9.81 plus the 4. Therefore, P2 is equal to 40.27 Newton per centimeter square. And the water is flowing through a taper pipe of length 50 meters and diameter 40 centimeters at the upper end and 20 centimeters at the lower end. If the pressure at the higher level is 24.525 Newton per centimeter square, find the pressure at the lower level. Take slope of the pipe to be in 1 is to 40 and the rate of flow is 60 liters per second. Length is equal to 15 meters and depth is 40 into 10 raised to minus 2 meters. D1 is equal to 20 into 10 raised to minus 2 meters. Then B2 D2 is equal to 24 point P2 is equal to 24.525 into 10 raised to minus 10 raised to 4 Newton per centimeter square. P1 is equal to how much? The 8 is equal to 5 into 14 10 raised to minus 2 the whole square divided by 4. Then it is equal to 0.0314 and we also know that Q is equal to A1 into V1. Therefore, 16 to 10 raised to minus 10 divided by 5 into 20 to 10 raised to minus 2 the whole square divided by 4 is equal to V1. That is equal to 0.416 and V2 is equal to 1.91 meters per second. So applying and slope is equal to 1 in 40, Q is equal to 16 to 10 raised to minus 3 meters per second. Then Bernoulli's equation is equal to P1 upon 1 plus V1 square upon 2G plus Z1 is equal to P2 upon 1G plus V2 upon V2 square upon 2G plus Z2. That is equal to 25 plus 0.011 plus 1.236 is equal to P2 into divided by 1009.81 plus 0.186 plus 0, that is equal to P1 is equal to 25.5 Newton per centimeter square. Bernoulli's equation for the real fluid. Okay, so this I will take in the next class. Okay, so today I will stop here.